Hello everyone, I am Prakhar Garg, Program Director at TCS and Direct, and I will be your host for the session Careers in Machine Learning with Dr. Gautam Schroff. Machine learning is a division of artificial intelligence that is concerned with computer algorithms capable of improving with experience. Since the focus is on the learning aspect, algorithms use a set of training data to enable computers to learn and do something they are not programmed to do. Machine learning provides us with technology to augment our human capabilities. According to a recent survey, organizations that deployed artificial intelligence grew from 4% to 14%. A closer look at the technology landscape revealed that all types of companies, from retailers like Walmart to telecom giants like Jio to pharmaceutical leaders like Novartis, are hiring individuals who are adept in machine learning. Job postings having artificial intelligence and machine learning as keywords jumped up to nearly 100% between 2015 and 2018. Moreover, professional networking sites advertises more than 9,000 machine learning jobs in India right now. As organizations continue to adopt novel technological solutions and keep developing their in-house capabilities, the demand for machine learning skills is likely to rise even further. In today's session, we have invited a very distinguished expert to talk about careers in machine learning. It is my pleasure and honor to welcome and introduce our guest speaker today, Dr. Gautam Schroff. Dr. Gautam Schroff is a Senior Vice President and heads TCS research across all research areas with about 23 years of experience in TCS. He has previously worked as head of TCS Innovation Lab in Delhi. Prior to this, he has been a faculty at IIT Delhi for about 7 years. He earned his doctorate in computer science from the Renaissance Polytechnic Institute, New York, in the year 1990. Dr. Schroff has published 2 books, namely The Intelligent Web, Search Smart Algorithms and Data Science and Big Data, from Oxford University Press in November 2013, and Enterprise Cloud Computing, Technology, Architecture, Applications from Cambridge University Press in October 2010. He has also published 100 research papers in various areas, including data science, artificial intelligence, and machine learning. He has been awarded with the Youngest Scientist Award from Indian Department of Atomic Energy in 1994. Dr. Schroff is an active member of Association of Computing Machinery, ACM, and has served on the ACM India Council and was the founding chair of ACM India Special Interest Group on Knowledge Discovery from Data. He was also a member of AI Task Force constituted in 2017 by the Ministry of Commerce and Industry by Government of India. We welcome you, Dr. Schroff. It is an honor to have you here with us. I would like to request you to please share with us your journey of becoming such a successful AI scientist and expert, and what does machine learning mean to you? Over to you, sir.
So I'll just take a few minutes to explain how I sort of wandered into this field. It's actually that kind of a journey. There was, a book. Then I went for graduate school in the US. That was what was called the AI winter. I mean, people had pretty much figured out that, AI is not going to work, and there was no funding at all available for any research in AI, right? So I wandered into some other fields wherever I got funding, and of course that time parallel computing was very hot, so I got into that. And once you get into something, it's natural inertia, sort of you take it up there. But I was always kept reading about AI and in passing, just for fun. And then sometime much later, sometime in the late 2000s, I was working in software engineering and software architecture. And I realized that the whole data architecture space was changing. If you remember, this whole big data term had come at that time. And there were these things like Hadoop had come, and there was all this NoSQL. And I started wondering what's really going on here and why. And at that time, I also started writing a book on enterprise cloud computing, as Prakhar mentioned. And then I had to write a chapter on, how data is being used, because you can't just write about data. And that's where I dug in and figured out how the web companies were using data, and I realized that there's something I'm missing here. It's a field which I was not into, and I need to learn about it. And so I really actually started learning only in about 2009 about this stuff. And in the next few years, I not only did many courses online, because the MOOC revolution had sort of started then. I also started writing a second book in 2012, and I also offered an online course at that time on Coursera called Web Intelligence and Big Data. They sort of went side by side. And so the book came out, the course ran for a couple of sessions. And then it turned out in a few years, the course became, and the book became totally out of date. So the field was moving so fast because that in 2012, deep learning hadn't really hit the levels that it hit. It came later. I mean, and Jan LeCun had just published his paper, which finally got accepted and was showing fantastic results. And if you hear his talks, I mean, he would say that his papers were rejected so many times in top venues before that. And so that it really started then. My book didn't cover deep learning; it just covered some hints of the initial work because the real explosion hadn't happened. And in the next 5-7 years, it really just took off, and I was very much involved in that, applying those techniques, learning about them, applying them to problems of our customers in TCS. And today where we are is that the state of AI and deep learning is such that if you look at let's talk of 4 types of problems. Say perception. Perception is almost a solved problem. I mean, from a practical perspective, looking at images, looking at speech, understanding translation, speech to text. Very, very well. These models just are amazing. In the 1960s, one would never imagine this is possible. The next thing is prediction. I mean, what's going to happen next? Who's going to buy next? Who's the next guy to put an ad towards? What's going to happen next in this data center? All that stuff is almost getting there, and those kind of models are doing well. And then prescription. I mean, what is the best thing to do in a supply chain, or what is the best thing to do in a complex data center, or in a complex distribution plant where you've got robots being controlled. So those kind of decisions are now being taken because AI and optimization have come together. And then lastly, participation. I mean, robots are now reality. I mean, in the lockdown, many of us have bought these robots which clean our houses. And that's because they have this SLAM algorithm which can understand the room. It's commodity. So there's a certain amount of commoditization of AI which has already happened. If you can buy robots which clean your room today, well, a lot has happened in this field. And if you can get speech translated and you can and pretty much get speech to text transcribed, a lot of what was envisioned for AI has actually happened. And getting started as a developer in AI is we've really moved beyond from what was our sort of assembly language programming just a few years back, the analogy, to actually commodity. We have high level packages and tools, auto ML. It's very easy to get started and get really good results with AI. So as a result, what's happened is the gap between sort of applied AI and core AI has really widened. So if you want to apply AI to a real business problem or a real life social problem, you don't really need to get into the assembly language of it. But it's very important to know the domain. Because just knowing how to train models is not really good enough for you to really solve problems today. Because the magic comes in the application. If you understand the domain well, and you know the right problems, the right questions to ask, and then choose the right approaches to take, then real impact can be made. And the second thing is that AI by itself cannot make an impact in most fields, apart from computing, like targeted ads and stuff like that. In real world, you need to actually do something in the real world, right? So, for example, drug discovery. At the very beginning of this pandemic, many researchers, including some of ours, applied AI techniques to search through a whole bunch of molecules and tried to find which were the ones which could actually help, whether it was to build therapeutics or control symptoms. And there are many, thousands of such molecules have been discovered, but how many are going to get synthesized? How many are going to get tried in vitro, then in animals? That the real world doesn't disappear just because we actually did something on the computer. So being very tightly coupled with the real life, the ability to act, is the only way today AI can actually make impact. And then for a specific application, with a specific detailed understanding of that domain, there's a lot of scope for innovation and applied research, especially when they don't have enough data. AI, deep learning, and all require lots of data. But when you don't have data, there are a lot of interesting things that you need to do which require your domain knowledge. So in some sense, the evolution of this field is like coding itself. I mean, in the beginning, in the 80s, you if you know how to program, it was fine. I mean, you're just a programmer, and anybody would just pick you up. But today, programming is no good. I mean, you need to know a domain. Programming in finance, or programming in in industrial computing. I mean, you need to know the technology to and its applicability and its specialization to domains. That becomes much more important. So that in some sense, historically, we've evolved. And lastly, core AI itself is very different. I mean, the goal of trying to understand how, I mean, in some sense, if you look at science, I mean, physics has understood the world fairly well. Biology less so, but so for even the pandemic, we don't really understand biology enough to even, we know so much science, we can't, fix this terrible disease. I mean, it's just, in some sense, nature has humbled us. And if it comes to human mind, it's the ultimate frontier. We just don't understand almost very little. I mean, minuscule a bit of what actually goes on. And in some sense, the kind of things that are happening in core AI now are going beyond sort of the vanilla. Things like learning to learn, meta learning, things like perceptual learning and reasoning, and how do we bring them together. These are all real unknowns. And so core AI is also a very exciting time to work in now. From a research perspective. So I hope I've given you some idea of my journey and some hints at what people should be looking at. Either you should really understand a certain area of applications or decide to become a core AI researcher, but very few will do that. But most people, if it's just applying models, they become commodity. So it's really need to understand domains.
Thank you, sir. Thank you. I think that was very important to understand domain as well, and at the same point of time going deeper into understanding of core AI as well. So that's really very important takeaways there for our audience. It actually also covers one of the aspects that few people think about AI as a kind of anti-human thing, which is not the case. It's actually evolving it as a next step, because sometimes, just like you mentioned in the pandemic, we were out of answers. We're not having an immediate answer. So these kind of technology will actually help us understand it much better, I think. So I think that answers few of our audience questions that they put in the pre-survey. So thank you for bringing that up, sir. Sir, I would like to ask you a question that has actually come up really a lot of times to me, is that while we are talking about intelligent machines and artificial intelligence and machine learning, we think about, like, we have most of us seen movies like Robot or iRobot. So, but these ideas are still very far-fetched. So can you just maybe give us some real-world examples wherein AI is right now changing everyone's life, or maybe some project that you are working right now?
Well, I mean, you use AI every day when you search or when you buy things, when you recommended stuff online. I think everybody knows that AI is already behind the scenes. And as I mentioned, it's being used in drug discovery, it's being used in materials discovery, it's being used in deep science all over the place. But you mentioned iRobot. iRobot is a company, and you can buy their robot to clean your house today. So, I mean, what's more real than that?
Yeah,
and it's using extremely sophisticated algorithms called, simultaneous localization and mapping to map out your room, so it knows where all the furniture is and where to park itself, and it just has to look around and see that the mapping is done. They're all cutting edge technologies which are now commodity. I mean, a SLAM algorithm, you can, dozens of them, you can just take it off the net and implement it on a robot. So, I mean, it's getting very real. So I don't see I think the challenge is the imagination. So when we have sessions, for example, we had a long session with a few months back with senior officers in the government. I mean, it was the people who are talking AI, that is us and other IT companies, were actually overshadowed by these brilliant young officers who are actually talking about the problems that they could probably imagine and try to solve. And we were overwhelmed that there is an imagination out there, and young and maybe even not so young officers who are working on the ground are able to imagine these problems, and then once you put the commodity tools and staff them with people and volunteers, they can solve real problems. For example, there's an application in one state where I think it's called Jeevan Praman or something, where you can actually, I learned about it in this conversation, that an old person, I mean, people who need their pension have to actually every year go and tell the bank that they're alive. And it's a tedious task for somebody who perhaps is in a wheelchair and can't, but this now they can do it on a mobile. The technology is able to say this is not a photograph, the person actually alive, he's speaking, etc. It's a brilliant use of technology, making people's lives easier.
Yes, I completely agree, sir. Even like we see real world examples such as self-driving cars right now coming in the market, and that's like reachable to everyone. Obviously, still it's a bit pricier compared to the other products, but obviously with time, these things will get into a more cheaper zone. So very, very interesting things that we have.
And you are using an ion as well, right?
Yeah. Yes, we are. Thank you. So, sir, another question that I was thinking about: what are the potential areas of specialization or sub branches within machine learning? Can you maybe elaborate on?
Well, I would say that there was a time, maybe 10 years ago, where where you could say I'm a vision person, or I'm a speech person, or I'm a natural language person. I think that those days have sort of gone away, and today it's much more come together, because if you do something in the vision area, you'd probably want to marry it with text and speech and sensor data. So it's very difficult today to imagine from an applied field somebody who's specializing in only one type of data, one type of technology. Deep learning is all over the place, and the best models keep changing every day. So I think the only way you can think of specialization today is, okay, they're just like you have Java, you have C, you have C++. There are certain frameworks which people have gotten good at using. So there's a TensorFlow community, there's a PyTorch community, and in some sense there are new ones coming up, and these will change much faster than programming languages. So in some sense people have sort of become experts in one or the other. It's not as different as programming languages, but in some sense that's a specialization. But the real specialization is in the domain. If you're really good at dealing with sensor data, all the peculiarities of the data, how to clean it, etc., versus dealing with speech or versus dealing with images in or video, and how to deal with the data, clean it, make sure it's correct, then there's some degree of, so not in the technique, but in the actual domain.
Thank you, sir. Thank you for pointing that need of having a data knowledge, domain knowledge, rather than having say knowledge of some particular technology in terms of languages. The domain knowledge is more important, which is very interesting. So in that regard, we are actually getting questions regarding this about people who are maybe in the same domain and they would like to switch to machine learning than their earlier, say, work of working in a programming language. So how can they transition if it's something like that?
Well, again, if you're working in a programming language, you've probably been applying computing to a domain, right? So best to understand your domain first, and then understand what else you could do if you had the power of some of these commoditized AI technologies, right? So suppose you're building applications, suppose you could put in, text into those applications, right? So what you do on a screen, you can do using just text or using just speech, or you could make it much easier for people who, for example, can't hear by just using some things which are now almost commodity, sign language and stuff like that. So you can start by just expanding the work that you're already doing. How does it actually, can it leverage commoditized AI technology? And so if you're focused on the domain, then whatever you do will be much more rewarding than merely learning a technology and say, now I'm a machine learning guy. I mean, machine learning is like just the next evolution of computing. So I think one should just view it that way and not a different field at all. It's the evolution of computing. All programming is going to start involving machine learning. There will be programs which will use algorithms, and then part of those algorithms will be machine learning components, which we learned. And it's just, if you think about machine learning, it's just an algorithm where parts of it are unknown and get tuned with the data. So more and more parts of the algorithm will start getting tuned, and more and more parts of the algorithms are going to start getting tuned on data together with many other parts. So it's just going to be an evolution. Similarly, the architectures which you're going to deploy things, today people are learning how to just train models and stuff, but really the challenging part is how do you deploy them. It's easy to build an image classifier. It's very difficult to deploy it in a mobile app with serving thousands of users and hundreds per second, and how does it scale and when does it get retuned. That ML sys, the systems part of ML, is people who know architecture well. They are the best people to solve this problem, not the people who know how to build the next better image processing model, right? Because the problems are the same. Data is coming in, has to stream, has to be stored, has to be the computing, what has to be optimized. It's the same set of skills. It's just a different set of situations, and all that comes from the application, right?
Right. So the experience in application and coding as well might be able to help them out in this perspective. So thank you, sir. I think that answers questions from a lot of our attendees. So what do you think is the reason for being such an increased demand of AI right now? And what is your thought of how it will look like, say, 5 to 10 years from now?
Well, like I said, it's getting commoditized, right? So there's going to be a time when merely knowing machine learning isn't enough. You'll have to know, if you're going to do machine learning for, natural language processing in banking, or natural language processing in medicine or in law. I mean, there'll be different nuances and different problems and different techniques which might actually work much better in certain situations, and only by experiencing those will you know, right? So I think that's the key to actually be applying it. Second thing is the reason for interest is obviously it certainly it catches the imagination that machines can do things which we never imagined they could do. But I think it's also becoming a little old. People are getting used to it, and the sort of average person in society is saying, of course machines can do that. Whereas 10 years ago, 5 years ago, said, no, that I can't believe machines can do that. Now it's like, of course, they do it every day. They do it on my phone. So when you say I'm doing this great stuff, your family may say, what the hell? The phone does it for me, right? So it's getting a bit old. So the interesting thing is going to be in the domains which are not yet solved, right? So whether it is, like I mentioned, science, drug discovery, or materials, or large scale complex decision making, right, in the real world, whether it is for supply chain, whether it is for planning or whatever, right? So I think those are the interesting real life problems where things are going to get much more used and applied. But at the same time, let's not lose sight of the fact that there is a lot of hype. And one has to sort of not merely ride with the hype. I mean, the number of seminars which are about how great AI is and is going to change the world. Well, AI, like as I mentioned, is not going to change the world by itself. It's people who actually are solving real problems, and this is another tool which is going to help you solve those problems better. But understanding that problem and having an imaginative solution is always going to be far superior than going around with a hammer and looking at everything as a nail.
Right, sir. Right. So the skills about like looking at this problem in a different way is more important, because that's where we actually going to train our machines to learn by themselves. So that is very important. So can we maybe focus more on what are some of the skills that are required to get into machine learning? There's some inbuilt skills, some maybe technical skills, some soft skills. What are some key skills that might help students to?
Well, I mean, a certain amount. I mean, if you know programming, I mean, if you know Python programming, you're sort of halfway there. Secondly, if you know, go back to your high school or college and college textbooks and just brush up on your linear algebra and probability, and then you're almost 80% there, and the rest you can learn online. And in my view, it doesn't take a long time to come up to speed today. There are so many good online courses, so many good online resources, and your books are there, right? And if you don't like books, you can always go and look at some online videos like your younger brothers and sisters are doing, or if you're older, your kids are doing, right? So I think the resources are all there. It's all in the mind that I am this and I am that. So the sort of last set of probably advice that I'd like to give answer this question is this is not the question to ask. I think you need to be look at that. You need to be fearless. I mean, anybody can learn anything. So I just like I just mentioned, I didn't know machine learning before 2009, right? So, I mean, and I've done many things in the past. I did architecture before I did scientific computing before I distribute. I've worked in many fields. So you should never be afraid of learning something. And then secondly, you should question everything. Don't take anything for granted just because somebody says so. Convince yourself and also keep learning, continuously learning. Right? So that's the mindset rather than a skill. Right? If you have that, you can learn anything. Yeah.
Yes, right. And obviously problem solving abilities and the mindset about that I'm going to learn and I'm going to get into this field, and obviously come up with solutions wherein the industry is not right now maybe not looking, but obviously that will help me to grow further.
Yeah.
So there is a question with respect to this as well. In continuation to this is, can you suggest maybe some legit source where they could maybe some portals or some certification, what kind of courses they could find online or maybe offline that are best suited to learn?
Well, for a long time, one of the easiest courses and one of the best courses is Andrew Ng's course on machine learning at Stanford, right? Right, it's become a little old now, but it covers the basics of machine learning. I think that's a very good course to use. And there's a course I used as my meta learning course as the first few lectures to get people up to speed on deep learning, is Jan LeCun's course at NYU. It's totally all the materials is open, and the first few lectures are just beautiful, and it's from the horse's mouth in some sense, from a Turing Award winner who's invented large parts of the field. So I would say legit means go for the sources who have invented the field, right? The later parts of that course might be a bit advanced, but the first few lectures are just beautiful, and you can easily pick it up, provided you know Python programming, and provided you're not afraid of mathematics a little bit, and you just brush up on your linear algebra and your probability and statistics, and you should be okay.
Thank you, sir. Thank you. I think our audience must be writing down those points. Yeah. So thank you for bringing that up. Sir, a very important question for fresher is usually how they can start a job in the field, because in the specific field, because machine learning is somewhere where most of the freshers right now are being asked for experiences or maybe some understanding or some project experiences in machine learning. So how can they start being a fresher into this field?
Well, ideally it would be to, you should have done some internship during your college. You should have done some good projects, right? But even if you don't, I mean, there are so many competitions out there, right? Some are difficult and some are easy, even if you don't win the competition, right, a Kaggle competition or whatever, if you just enter it and do reasonably well and post your code on GitHub, that itself is an addition to your resume and shows that you can actually solve a problem, and people will look at that. I mean, when I look at an internship application, for example, even if the CGPA is not very high, but if the guy has 5 projects on GitHub and the code looks good, we look at it. But I think most people would look at that, the work that you've done. And it's very easy now to get your work out there. The community is so open now that it's fairly easy. It's a matter of the mindset. Get your hands dirty and do something. My favorite way of relaxing is coding. If you're like that, then you're in the right place. Okay. So
thank you, sir. Thank you for the answer, sir. There's like a lot of questions that we had in the beginning as well, like how someone from a non-IT and non-computer science background can maybe try for machine learning. Like is it path simple for them, or maybe again they have to go and search like jobs certification or some examination separately?
Well, I think it's a good idea to I mean, if you've done an undergraduate degree in some other discipline, it's a good idea to do a master's in computer science, obviously, I mean, if possible. If not, like I said, the domain is important. Learning machine learning is much easier than, say, learning biology, in my view, right? Or learning chemistry, or it's much easier than that, right? So if today you were to ask me to go and learn biology, I would need another lifetime to learn it. I mean, certainly couldn't learn it at my age, but I could pick up machine learning 10 years ago very easily, even though the field had not evolved too much yet, because I had a core background in computer science and stuff like that. So I think it's very important to realize that it's not that difficult, especially if you have an undergraduate degree which has good mathematics and you know programming, right? So that's all you really need: some basic mathematics and a good handle on programming, and then it becomes easy. Of course, if you don't know programming, it becomes much more difficult. So you have to learn that first. You don't need to necessarily know all of computer science to get into machine learning, right? But it's nice to be a computer scientist, because there are a lot of problems which are basic, and but I think that the answer is pretty obvious. If you ask me, can I learn biology today? I'd say definitely not. I mean, I don't think I can, right? So machine learning is easier.
Thank you, sir. Thank you. So let me try to take a few questions from our audience. So there is this question from Shivendra Chand, and he's asking, what are your views on confluence of AI, blockchain, and psychology?
Well, I don't think AI and blockchain have too much in common, except that they are buzzwords today. So, I mean, to be very honest, if people put too many buzzwords in the same sentence, then my impression is they probably don't know what they're talking about. Okay, so that's there. Right? Blockchain is a very different technology. It's let's not get into it today. Distributed ledger and all that. So, but this has very little to do with AI and machine learning, right? Except that it's also a hype technology. Psychology, I really don't have an answer, right? Because a lot of the core questions of AI, of consciousness, attention, how people learn, are influencing AI research, right? Because what people have learned about how children learn and how people attend to things and how many things we can keep in memory are influencing AI architectures and research. So to that extent, I think, yes, there's a lot to learn from psychology and neuroscience and behavioral sciences, because that's ultimately the only real example of something intelligent is a brain, whether it's a dog's brain or it's your or my brain. I mean, that's all we have. I mean, we don't have any other exemplars in this world, right? So we have to study them.
Right. Thank you, sir. Thank you. So let me take another question from Anantu Sugathan. I'm a final year aerospace engineering student. I would like to know about recent ML application and projects happening in aerospace.
So aerospace, there's clearly a huge an interesting area. For example, many of the control systems today, for example, on a drone, right, are in some sense autonomous drones or autonomous UAVs are the precursors to sort of self-driving vehicles. I mean, but do they use AI end to end? Probably not. They use AI in pieces. They use vision. They use PID controllers. They use even a self-driving car is not an end-to-end AI system. It's an engineered system where components use machine learning or vision, and they're sort of assembled together, because ultimately you don't want it to crash. And certainly I don't mind flying in a plane which has some AI components, but I wouldn't fly in a plane which is trained by a deep learning model. Okay, today. It just doesn't, it's not robust enough at this stage. It has to be properly engineered. You have to have control laws. You have to actually, it has to be stable. You can't guarantee those things with machine learning. But yes, certain pieces of the puzzle can be better solved with machine learning and with adequate testing, and you can get involved with that, right? For example, in remote sensing, for example, there's a lot of use of machine learning. Whether it is looking at satellite images or looking at synthetic radar images, if you're talking about extension of aerospace to just the space part, definitely a lot of machine learning, because traditional image processing techniques have been overshadowed by machine learning techniques. So that's a kind of a no-brainer.
So I think we are very close to our end time. So let's try to wrap up the session, and would like to request you to share any final advice, any suggestion for all the budding young professionals in the field of machine learning and artificial intelligence.
See, I think it's important not to get carried away by the hype. You will be much more useful to any employer or even to yourself if you focus on what kinds of problems and what kinds of solutions are interesting to you, and try to solve them, right? And it's so easy today. I mean, you can build mobile apps in a jiffy today, right? You can deploy solutions which are interesting. You can put up the code for everyone to see. It's just a matter of making yourself visible. So Jack Welch, the famous CEO of GE, long back, he wrote a book. I forget the name of the book, but his thing was get out of the pile. You have to dazzle, you have to shine, you have to show that you are different, and that's the name of the game. Because whatever you may say, competition is there. There are just so many more of us all around, and the path is much harder than perhaps when I was graduating and going to and joining college and then later on. I mean, just sheer increase in population. I think there's a lot of competition and there's a crowded space. So differentiate yourself, learn about a particular area, learn it in depth, and do what you can, because there are no limits if you're fearless and keep learning.
Yes, there are no limits actually. If you just keep on learning, then you obviously can grow further and further. So thank you, sir. Thank you. I'm sure the scope of machine learning is limitless in the global current context. Your critical thinking abilities, married with awareness about latest market trends, can set you apart from the crowd. If you're aspiring to become one of the best machine learning experts in India, the salary packages that you might get as well is very interesting. So career growth, job security, reputation, and all these things make the career really attractive. So with that, I would like to conclude our webinar, and thank you, Dr. Schroff. Again, it was a pleasure hosting you today. It was a really insightful talk. Thank you, sir.
Thanks, Prakhar. It was fun, right? I hope it's been helpful. Bye-bye.
Sure. Thank you, sir. Bye-bye.